Hello everyone, welcome to today's video. In this video, we will be talking about first order logic which is used in artificial intelligence. Now, talking about logic representation, when we were doing propositional logic, we talked about how we can represent statements using propositional logic. That means how we can convert different facts into statements and then we can represent them using different symbols. Okay, but unfortunately in propositional logic, what happens is we can only represent the files which are either true or false. So talking about propositions or propositional logic, we cannot handle complex sentences or complex statements. So we can either represent a statements in the form of true or false. Okay, so propositional logic is not sufficient in order to represent complex sentences or general natural language statements. The propositional logic has very limited expressive power. Like for example, if we are considering let's say some men are intelligent. Now we do not have any such scope of representing the factor some, okay, or for all. So these kind of things we do not have any representations. We can represent simple sentences or simple atomic sentences like the sun rises from the east. This is a universal fact, right? So those things can be represented using propositional logic, but factors like for some or for all those concepts, or let's say a very particular person, like let's say Sachin likes cricket. Okay, so these kind of sentences cannot be represented using for propositional logic. For this we have to have some more powerful logic, such as the topic of discussion today, which is the first order logic. Okay, so talking about the first order logic, let me write it down. First order logic, or in short we can also call it as FOL. So for first order logic, it is also known as predicate logic. The first point we have to remember is that we can also call this first order logic as a predicate logic. It is another way of knowledge representation which is an extension to your propositional logic, which means that predicate logic basically is propositional logic plus some powerful factor, okay, plus x, and this x is basically representing complex sentences. Now it is sufficiently expressive to represent the natural language statements in a very concise way. Okay, it does not the next important point we have to remember is that it does not simply depend upon the world or the facts of the world, uh, as we have seen in the propositional logic, but it also assumes the other parameters which are associated to the world, like objects. Okay, facts it will definitely consider, like objects, for example your A, B, let's say numbers. Okay, all those things, these things will be considered. Wars, theories, squares, pits, wumpus, all those things would be considered. We will also look into this into detail when we will do some examples. Okay, the next one is it can also consider relationships. Now these things were not considered in your propositional logic. It can be a unary relation, like let's say it is around or it's adjacent, something like that, or an n-ary relation such as sister of, brother of, or the color and or what comes in between. So all those relationships would be considered. Okay, so it can be either a single relation or a n-ary relation. Okay, as well as they can also consider various functions. So functions may be the father of, or the best friend, or third inning, or end of. So all these functions, okay, these can also be considered when we are using this first order logic or the predicate logic. Now talking about this first order logic or the predicate logic, like any other logic representation or in any other format of representation of knowledge, it is considered or it is comprising of two main parts. One is the syntax, the next one is the semantics. Now, by literal meaning, if we are considering syntax, it will determine which collection of symbols is logical expression of the first order logic. So essentially, we have to consider the symbols in syntax and the meanings in semantics. So, the first and the basic syntactic element of this first order logic are basically symbols, and we generally write statements in shorthand notation in first order logic. Okay, now these symbols, they generally do not simply are just one letter or one character. Okay, it comprises of different parameters again within these symbols. Okay, so these symbols can take care of constants, then it can also take care of variables, then it can take care of predicates, it is also capable of handling functions, and then it is considering connectives as well. So some of them are common to what propositional logic we have already discussed. Some we will find as new ones. So equality is there, and then we have one more, which is the quantifier. Okay, so constants can be anything like values 1, 2, A, then India, as such. Variables, they are simple variables where we can store different elements. Okay, A, B, X, Y, Z. Predicates, they can be brother or father or less than or greater than, etc. Okay, function can be square root. Let's say we have a simple interest calculator, so simple interest, etc. Connectives, again, we have already seen in our truth table. So we have connectives as and, or, not, implications. So all these are there. Again, equality, it is represented using two equal symbols. And quantifiers, we have two quantifiers. One is for all and the other one is for some. Okay, so this we will be talking about when we will be doing existential quantifiers as well as existential quantifiers as well as universal quantifier. Now for all is basically for all is considered as the universal quantifier, and reverse of this symbol is considered as the existential quantifier. We will see this when we will do the examples of it. As of now, we have to understand that syntax is comprising of these symbols, and the symbols would be able to take care of these many factors. Okay, then the next important point that we have to discuss about this is atomic sentences. Now, predicate logic is capable of representing complex sentences, which does not deny the fact that it cannot represent atomic sentences. Atomic sentences are the most basic sentences of first order logic. That means we have to represent, or we can represent, or we should represent first order logic using, or any logic using atomic sentences. Then these sentences are formed from a predicate symbol followed by a parenthesis with a sequence of terms. So considering this, that means we have atomic sentences, and these atomic sentences are formed from a predicate symbol followed by a parenthesis with a sequence of terms, and then we can consider it to be a first order logic representation. So how can these atomic sentences be used? We can simply use a predicate followed by terms, term 1, term 2, then term n. Now this will be more clear when we discuss this with an example. Suppose let us consider Ram and Sham are brothers. So Ram and Sham are brothers. So how do we represent this? We have to represent this using a predicate, which is basically we will consider predicate as brothers. Okay. And here we will use the two terms, which is Ram and Sham. So we have atomic sentence saying that Ram and Sham are brothers. That means we have a single sentence which is saying Ram and Sham are brothers, and this can be converted into first order logic by considering a predicate and the terms which are there inside that particular sentence. Let us take another example saying that Bruno is a dog. So here we can use another predicate saying that dog and then Bruno. Okay. So this is how basically we can represent this atomic sentences. Okay. Now talking about the next important parameter, which is complex sentences. So we saw how we can represent atomic sentences. Now we will see how we can represent complex sentences. Okay. So complex sentences are nothing but they are made up of combining atomic sentences by using connectives. So we have sentence 1, sentence 2. If we are considering any of the connectives like and or not, so this will basically represent the complex sentences. Now here the first order logic statements or the predicate logic statements can be divided into two parts. So we have FOL statements, that means the complex statements. Okay, so these statements we have to divide the statement into two parts, one being the subject and the second one being the predicate. So subject is the main part of the statement. So this will form the main part which will actually reflect what should be the main content of that particular statement. And predicate can be defined as the relation between those content or relation between those terms which bind the two atoms together in the statement. For example, if I am considering A is an integer. So if this is a particular statement that I have to represent, okay, it will consist of two parts. The first part, A, is basically the subject, and the second part we can consider this as a predicate. So subject and predicate both will be combining in order to represent the complex sentences. Okay, so similarly if we have two sentences we can also combine it for that. Now talking about the next one, which is the universal quantifier. So the quantifiers. Okay, so one different component of the syntax which we can see from uh, the propositional logic is basically the quantifier in first order logic. So quantifier, it is basically a language element which generates quantification. It is nothing but it will give you a natural language feel about the sentence. So it is a language element, and this will be generating quantification. That means how many, generating quantification. It will quantify what and how many subjects are actually participating in the particular representation, and it specifies the quantity of specimen in the universe of discourse. Okay, so these are the symbols we have already seen which takes part in these two symbols will be taking part in quantifiers. Okay, and it will be it will determine or identify the range and scope of the variable in the logical expression. Okay, so this one, the first one, we will consider as universal quantifier, and it can also be said as for all or everyone or everything. For all, everyone, or everything. Okay, the next one is existential quantifier. So this is not quantifying, or existential, yes, so this will not be quantifying for all, but it will be quantifying for some, that means special cases, or at least one. So we will not be considering all of them or none of them, we will be considering at least one participant or at least one subject to be incorporated here. Okay, so talking about the first one, which is universal quantifier, it is basically a symbol of logical representation which will specify the statement within its range is true for everything or every instance of a particular thing. And we have already seen the symbol to be this. Okay, it is used for every instance or for everything of a particular thing. Now, if I am considering if x is a variable, okay, so if x is a variable and we are representing this as for all x, it will mean that this representation is true for all x, for each x, as well as for every x. For all x, for each x, or for every x. Like, for example, if we consider that all girls have long hair. Okay, so all girls have long hair. So if we are considering it to be let's say, it will mean that for every girl or each girl will have long hair. Likewise, let us consider another statement which is represented as all boys drink tea. So no matter whatever it is, if we are considering x and x belongs to the set of boys, that means suppose this we can also represent this with the this we can also represent this with the value as x1, x2, x3, x4. Now dot 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 and xn. So x1 might drink tea. Yes, x1 will drink tea. Let's say x2 would also drink tea. x3 will drink tea. Likewise, xn will also drink tea. And all these factors correspond to the factor that x1, x2, xn3 dot dot xn. So all these belongs to a universe of discourse which is man, right? So if we are considering this representation, we can represent them in a first order predicate logic or first order logic with the representation is that for all x, if x is a man, or sorry, if x is a boy, we considered it as a boy. So if x is a boy, then definitely x will drink tea. Okay, so if for all x, that means all boys is covered in this representation. For all x, we are considering x to be a variable which is representing the universe of discourse which are basically boys. So this we have mistakenly written as man. we will have to write as boys. Okay, so X is basically the universe of discourse, a variable for the universe of discourse, which is this boys, right? So if X is a boy, then definitely X will drink tea. Okay, so this is basically how we can represent a complex sentence or a quantifiable sentence using first order predicate logic using universal quantifier. Now we will talk about existential quantifiers. So these are the type of quantifiers. We will talk about this symbol now. Okay, so this existential quantifiers, basically they are the type of quantifiers which express that the statement within its scope is true for at least one instance of something. So this will represent at least one, okay, and it is denoted by the logical operator, this particular symbol, which resembles an inverted e, and when it is used with a predicate variable, it is called as an existential quantifiers. Okay, so suppose we are considering x is a variable, then if we want to represent at least one instance of x, then we have to write down as this. Okay, and there will be this would be represented as there exists ax, or for some x, or for at least one x. Okay, so these are basically the symbols which would be used. For example, if I'm considering some boys are intelligent, now this would be representing some boys, okay, some quantification here, where if I'm considering variable x, so x1, x2, x3, x4, xn, they will be the universe of discourse and they will be considered as intelligent. Okay, so suppose I'm using this for x. Okay, for x, if x is a man, oh sorry, if x is a boy, then x is intelligent. Okay, so this can be represented as, let's say, boy. If x is a boy, then x is intelligent. Okay, we can also consider the previous representation where we have written it, or where we can write down like this: for x, if x is a boy, then x is intelligent. So we can also represent this, and this is another way of representing, sorry, so this is another way of representing it. Okay, so x, for all x, if x is a boy, then x is intelligent. Okay, but this will be more appropriate in this scenario, because unlike there were two subjects here, we do not have two quantifiable subjects in this particular sentence. We just have an abstract or an adjective here. So this can also be represented in this way. Okay, x is an intelligent boy. The representation of this is what? X is an intelligent boy. Okay, but this would be more appropriate where x is a boy and x is intelligent. Okay, it is entirely up to the person or the representer how he wants to represent it. It only has to be represented in using the correct formalism. Okay, the next one we have to remember is that the main connective for universal quantifier is implication. Okay, so when we are considering this, the main connector between the logic representation statements or representing statements is basically the implication symbol, and the main connective for existential quantifier is basically the and symbol. Okay, so this we have to keep in mind. Though this representation is not incorrect, or it is not wrong, we have to make sure that if we are using existential quantifiers, we go for a and connective instead of an implication. Implication is generally used for universal quantification. Now, talking about some of the properties of the quantifiers. So, in universal quantifiers, first point we have to remember is that for all x and for all y is similar. Yes, it is similar to is similar to is similar to for all y and for all x. We can reverse the statements, no problem. Similarly, in existential quantifiers also, in existential quantifiers when we are using for for one instance of x or for some x and for some y is similar to the reverse of the statements. It shows absolutely no problem in representing. Okay, so for all for some x and some y, it is similar to for some y and some x. And the third important factor we have to remember is that for all x, sorry, for some x and for all y is not similar to for all y and some x. We cannot go for combination, a reversal of the quantifiers. That is not allowed. Okay. Now let us write down some of the examples using the first order predicate logic. So the first example that we will do is all birds fly. So when we are considering this statement, what do we notice first is here we have one predicate and one subject. Okay, so if we are having one predicate and one subject, so fly is basically the predicate and bird is basically the subject. We also have a quantifier here. So now if I am representing this with a variable for all x, if x is a bird, then x can fly. Okay, x can fly, right? The next one, if we are considering, let's say every boy respects his mother. Every boy respects his mother. Okay, so the predicate here is respect. Okay, respect, and there who respects whom? Every boy respects his mother. Okay, so there are two terms which are associated here with the predicate respect. Okay, so we will consider boy to be x and mother to be y. So now we are considering, now we are considering that for all x, if x is a boy, for all x, if x is a boy, then x would respect his mother, and we will join it using the predicate. Okay, respects his mother. So this is how we will represent the universal quantifier and complex sentences using first order predicate logic. Now let us consider the existential quantifier applications. So this one is 3. So some girls cook food. So let us consider this. So here the predicate is basically cook, and who cooks what? Basically some girls cook food. Here we will consider girls to be x and food to be y, right? These are the two terms which are there, and there are some girls, so we will use the existential quantifiers. So some girls, so here we will represent that for some x, if x is a girl, okay, then X will cook food. X will cook food. Okay, here we are using implication. However, you can also use and operator. So here, since I find that implication is much more suitable, so we have represented it using this particular statement. Okay, now let's say we have a little complicated statement. Okay, what is that complicated statement that we will be handling, right? So suppose, let us consider the last example. Okay, only one student failed in science. Okay, now how would we represent this using predicate logic, or how we would represent this using logic? So if we are considering this, we do not have any option of using propositional logic here. We definitely have to use predicate logic because it is a complicated statement. Now the predicate basically here is failed. Now who failed what? Basically a student failed in a subject, right? So let us consider this first, that failed is the predicate and we have X and Y here. Now X basically is the student and Y is the subject. Now there is only one student who failed in one subject. Okay, so this is also selective criteria about the student, that is only one instance of the student fail in just one instance of the subject, not all the subjects, right? So we have to represent this using a different notation. That is, first we have to write down what are the representations. Okay, so when we are representing this, we will use for some X. So student, if X is a student, then X failed in mathematics. Oh sorry, in science, right? We used in science. That student failed in science. Now this is just a basic representation, so if we do not need this bracket here, so for some X, if X is a student, X failed in science. Now we can also categorically symbolize, or we can represent that mathematics is also not a generic subject, but it is a special case of the subjects. Okay, so that we will be discussing more when we will talk about free and bound variables. So as of now, just we have to represent some of the complex sentences, or we have seen how we can represent some of the complex sentences using predicate logic. So we will, or first order logic, we will look into more of this with certain examples, and there are various ways in which we can actually come to a conclusion about different different representations, and we can actually find out what is the final outcome by making use of different variables and different representations. Okay, so as of now, let us wind up here. We will talk more about this in my next video. Thank you.